about numbers. I'm going to be teaching you in like what parts we can separate them in, and like all the types that we have. So to start off, we have two main ones. So there are the real ones and the imaginary ones. So we have first real numbers. The imaginary ones, I'm going to be showing you them. I'm going to show you at the end. So right now, let's just focus on real numbers. So real numbers, we can separate them into rational numbers and also into irrational numbers. So, okay, now we're going to go with the irrational numbers. Now, rationals, we can separate them into integers, also whole numbers, and in natural numbers. Now, all real numbers, to start off, like the main definition that we can give for real numbers is all numbers that have a certain pattern in their decimals. So at one point or another, no matter if it's big or small, the decimal, it has to end. To start off, we're going to see first the rational ones. So we write here, rational. There are all those numbers that that end at some point. You know, so first, like, all rational numbers can be like 9, the square root of 9, because we all know that the square root of 9 is 3, so it doesn't have any decimals left. But we can have decimals, but for example, they can either be two types of decimals. If they have a certain pattern in them, like for example, let's say 9.3636, and so goes on. But, so you can see here that 36 repeats itself, so it's a pattern. So we would classify this one as a rational number. Now, other type of decimal is that it just continues on and on the same number. For example, 2.77777. So we can see in all of this that it doesn't change the number, so we can have decimals. But for example, when it comes to having numbers such as square roots that don't really end at some point, like 5, you know, it has like infinite decimals. Or also, which ones? For example, 2.3784. You know, it just like it doesn't have a certain pattern. So this we would classify them as irrational numbers. Irrational numbers. So irrational numbers are just the ones that don't end the decimal. The decimal doesn't end. Now, back to the rational ones. Rational numbers are like, it can either have as a normal number, it can also be, now that we understand the concept of rational numbers and irrational ones, we can pass to like, it's still in the same part, but it's like a little bit more specific. So let's jump into integer numbers. So I'm just going to write integers. Okay, integer numbers are pretty much the same as rational numbers, except that we can have all of them. For example, integers do not include fractions. So for example, in rational numbers, we can have 3/4, 6/3, and so goes on. But now we can have, in the integers, we can have this. We can have negative numbers, we can have positive numbers, we can have all those numbers, except as well as irrational numbers. We can have numbers that continue like they're on the decimal, can't go like on forever. So in this case, the only thing we have to remember is that they're exactly the same as rational numbers, except that it can't have any decimals left, or it can have as well, it can have, how do you say, fractions. So integers, let's just write integers. No fractions. Or decimals. Okay, perfect. So those are integer numbers. Now I'm just gonna erase this part. Now that we understand which rational, so we don't need this anymore. And we're gonna pass to the next topic, or not topic, it's still not from the same topic, but whole numbers. So whole numbers. Now, this ones don't include either rational, irrational, integers. They don't include any of those. So what this means is just, they don't include any irrational numbers, although they can include some of the rational ones, but it has to be even more specific than the integer ones. So let's start off like integers. Let's just write like a small definition so we get this more clear because I just messed up a little bit. Whole numbers can't have any decimals, fractions, and includes 0 but cannot be negative. So includes 0 and can't be negative. So whole numbers include 0 and can't be negative. So some examples would be 34. At this point we can also have square roots, but the only condition for them to like be in this topic as well is that they have to like end without no decimal. So for example, we can have 36, 81, and whatever. We can also have fractions, but they can be simplified like how do you say? For example, if we have 2 fours, we can't have this one because if we simplify it, it would be 1/2 that is the same as 0.5 and it has a decimal, so we can have this one. But if it was 4 halves, this would be, I'm just going to erase this one. Wait. So if we have 4 halves, this is simplified as 2. And 2 is, it's not negative and it is positive, so it can be a whole number. Now, now that we got this out of the way, we can start off with the last one. So we already saw which ones are irrational numbers, which ones are the rational ones, integers, whole numbers. We're going to go with natural ones. So at this point, we almost covered all of real numbers. The last one we have left is the natural numbers. Natural. So this ones do not, it's very simple. I'm just going to explain it really fast. Does not include either any of the ones that we have left, so does not include 0, does not include negatives, decimals, or fractions that don't and that can be simplified into a number without a decimal or either fraction. They can still be some square roots and like divisions and stuff, but they always have to end like how is it without zeros. It can't be 0 without negatives or decimals. So, for example, natural can only be 9, square root of 9 because this would be 3, and 3 does not have any negatives, doesn't have any decimals or stuff. So, after this, it can be 27, 9, 144, like all numbers that don't have any of this. And the last one I want to talk about are the imaginary numbers. This come in a really like this one's the other big like title we have. So it's imaginary numbers. Imaginary. This can be all numbers. Like it is all numbers that can't be identified in the number line. So, very simple. Real numbers, all numbers that can be identified in the number lines. Imaginary numbers, this cannot be. And how can you like find one that is not in the number line, you may ask? Also, for example, 1, 2, minus 1, minus 2. So you like all numbers that have like this little I at the end are imaginary numbers, and there's way more real numbers than imaginary numbers, or at least you won't see a lot of imaginary ones. but you're still classified as one of the topics of numbers. So that's it. And thank you very much for watching. I hope you understand. I know I got messed up in some parts.